Okay, folks, I'm going to give you some help with question 2 on the assignment. I've got a few emails already, and I'm sure there will be more to come. So here we're talking about the Persian and the Siamese cat. And how they're going to be crossed or mated. Okay, a couple of things before we get started. First of all, we need to have a letter to use for the alleles. So let's think about this. What's our trait? Our trait is long and short hair, right? Long hair and short hair. Now, we're not going to use a P and an S because we're not talking about the kind of cat. And you have to make sure you use the same letter for both alleles. One's a capital, one's a small, but they have to be the same. So what should we use here? Well, we could use a P, a big P and a little p, but those look too much alike. Hard to tell them a difference. When you start writing, you're going to get confused. Let's not do that. Same with S. Big S, little s, too much confusion. So I think what we should use is a letter that isn't going to confuse us. How about we use H for hair, since we're talking about hair. Now, it says in the question that long hair is recessive and short hair is dominant. So short hair gets the capital H and long hair gets the recessive H. Okay, so now, what do we know? Well, let's start with the Persian cat. Persian cat is true breeding. He's a true breeding, and it describes the Persians as having long hair. True breeding long hair means that nowhere in this Persian cat's ancestry was there ever a short-haired cat. It's been true breeding, long hair, long hair, long hair the whole time. Which means the only possible option for the Persian cat is this combination of alleles. Because if it ever got one of these from mom or dad or grandma or grandpa or great-grandma or great-grandpa, that would mask the recessive allele, and this combination would produce a short-haired cat. But it's because it's true breeding that we know that's never happened, so there are no short-haired cats in this family history, which means the only alleles are the small h's, the recessive alleles. Okay, so we know the Persian cat genotype. Good. Now let's talk about the Siamese cat. The Siamese cat, we don't know. He's unknown. So that means it could be a double H. That would cause it to be a short-haired Siamese cat. Could also be this, which is also a short-haired Siamese cat. And it could even be this, I suppose. It could be a long-haired Siamese cat that's been bred somehow. So these two produce a short hair trait, and this one produces a long hair trait. Let's see if we can eliminate some of the possibilities by looking at the kittens. Now, some of you are confused about the number of kittens. You said, oh, there's 6 kittens and there's only 4 squares in the Punnett square. You have to read carefully the examples I send you, because without me being able to explain them, sometimes you miss things. So in the example, it stated that the number of kittens does not matter. The Punnett square does not show the number of kittens. It has 4 spots that are going to have things in it. And these spots are going to tell us about the probability or the chances, or the chances of having a particular trait. The Punnett square applies to each and every kitten in the litter. So when a first kitten is born, if it's 25% short hair, that means that when he's born, he'll have a 25% chance of having the combination for short hair. It does not have anything to do with the number of kids. However, the kids do tell us something important. The number of kids doesn't matter, but the fact that there were in the litter, there were both short and long haired. It doesn't matter how many. Even one is enough. There was short hair and long hair. That means that at least some of the kittens, to get this long hair, guess what? Some of the kittens had to be double recessive, homozygous recessive. Because look up above. I'm going red here. Look up above. Short hair comes from these two. There's only one way to get long. So if you're a kitten and you got long hair, this must be your genotype. So if we work that backwards, let's think about how this works. Well, those H's are the gametes. This one came from the sperm, and this one came from the egg of mom and the sperm of dad. But we have a problem. We know that mom, or let's call the Persian cat mom for now. It doesn't matter which is which. But we know the Persian cat is HH. So let's think about how we could cross these. How do I cross this one with one of these to get some cats with long hair and some cats with short hair? So what I'm going to do, I've ruled out this one. That will produce only short-haired cats. Because let me show you. If you have HH and you're crossing it with HH, well, if you do the Punnett square, guess what? You're only going to get H's that are small. So there's no chance of getting a capital. The capital allele doesn't exist in this cross. So we know that can't be the case because some of the kitties had short hair, which means that some of the kitties had to have a capital H. Okay, so that means that it could be either this one or this one. So we need to just do 2 quick crosses with these two to see. So let's do the first cross. If we take the Persian, which is HH, and we try this combination to see what will happen. Well, actually, let me do the other one first because I know what's going to happen. So let me do this version first. Let's do the double HH first. Well, let's do a Punnett square and see what it tells us. So here we go, oh, my mistake. I'm going too fast, sorry. Okay, here we go, HH. Okay, there's the mommy. HH, there's the daddy, right there. Sperms and eggs. Let's cross them together, see what we get. They're all the same. And they all have a capital H, which means 100% of these babies will always have a capital H in them, which means they will have short hair. There's no way to get a long-haired baby out of this combination, but we had long-haired kittens. In the litter, there were some long hairs. So we know that that can't be the case, which leaves us with the other combination, which is this one. And we can check by doing a quick Punnett square. Mommy, daddy. Let's cross them. And we see that some of the combinations, actually half of them, will produce this. So this has to be the case. This has to be one, and this has to be the other, because no other combination will give us kitties with long hair. It doesn't matter how many cats there were. So now we know that the Siamese, the true breeding Siamese, the Persian, the true breeding Persian was this, and the Siamese, because of the way the kitties turned out, has to be this. Right? Now, if you're sharp, you don't need to do the Punnett squares. You can just look at the combinations and quickly cross them in your head and imagine the combinations you would get. You know that in order to get short hair, you have to have a capital H. But in order to get long hair, you have to have 2 small h's. So the only way to get 2 small h's from here is if one of these happens to be a small h. So you can tell right away the Siamese has to be heterozygous. Otherwise, if it was homozygous, it would not donate small h's, and you can never get any babies with long hair. So that's how you determine the genotype of the Siamese cat, going backwards. So look again at the example number 2, example number 2 that says working backwards. And it goes over that with you. And that's how you figure it out. Okay.